In this video, I'll be solving the first part of the second problem of UPSC Civil Services Mains 2019 Statistics Paper 1. So x1, x2 and so on xn is a random sample from probability density function. So f of x given theta is theta into x to the power minus 2, where 0 less than theta less than or equal to x is less than infinity. So we need to find what is the sufficient statistic for theta. We also need to find the maximum likelihood estimate and method of moments estimate of this theta. So x1, x2, and so on xn. This follows this density f of x given theta as theta to the power x minus 2, which is theta less than or, and when this is happening when theta is less than or equal to x less than infinity and theta is greater than 0. So it's a Pareto type density with the scale theta. So therefore the joint likelihood of the sample is L theta for this sample x1 to xn would just be the product I is equals to 1 to n. Product I is equals to 1 to n theta xi to the power minus 2, which is theta to the power n indicator minimum of xi greater than or equal to theta into the product I is equals to 1 to n xi whole to the power minus 2. So if we can consider this as z of t of x comma theta, and this is our h of x. So by factorization theorem we can say x of 1, the minimum order statistic, is sufficient for theta. So that would be the sufficient statistic. Now for likelihood L of theta, so if we consider the likelihood again, theta to the power of n, product xi to the power minus 2, for 0 less than or equal to theta less than or equal to x1. So we can see L of, so like for an allowed theta, this theta to the power of n is increasing in theta. So therefore likelihood is maximized at the largest allowed value of theta, and the largest allowed value of theta is x of 1. So that means the theta hat MLE would just be the minimum order statistic, which is minimum xi. So the PDF here would be, so if I find the PDF, so that will just be n times probability of x greater than t whole to the power n minus 1 into f of t. So that is nothing but n into, so this is theta to the power of n into t to the power minus n plus 1 when theta is greater than or equal to 0. So expectation of x of 1 is nothing but integral 0 to infinity tn into e to the, theta to the power n into t to the power minus of n plus 1 dt, which is nothing but theta to the power of n into, so we will be having like t to the power minus n, so minus n by minus n plus 1, so we will be getting n by n minus 1 into 1 by, so theta to the power n minus 1, so we will be left with n by n minus 1 into theta. So therefore theta hat will just be n minus 1 by n x of 1, which is nothing but unbiased estimator of theta. We can also check that it is consistent as n tends to infinity, the variance is tending to 0. So for method of moments estimator, expectation of x is integral theta to infinity x into theta into x to the power minus 2 dx, which is theta to infinity x to the power minus 1 dx, which is theta into ln x going from theta to infinity, which is infinity. So therefore the first moment is diverging, so the method of moments estimator does not exist because expectation of x is infinity. So that's it for this video. We'll meet in the next video.